Next 14th question, in which we normalize the values. Values are given here using the method A minus D. Step 1, statistical calculation. So data we have given here, and which is number of data is 5. So the minimum value is 20 and the maximum value is 1000. So our mean is 500 and the standard deviation sigma, uh, which is uh, 282.8, and our mean absolute deviation is 240. Now step 2, which in which we apply normalization, min-max normalization. So the formula is V minus 200 by 1000 minus 200, which is V minus 200 by 800. Next, we have z-score normalization, which is mu is equals to 500 and sigma is equals to 282.8. And then we apply the formula. So our z-score normalization will be 1.77. Next, we have z-score with MAD. Mu is given 500 and SA is given 240. SA is our mean absolute deviation. We apply the formula, and our minimum value will be 1 point minus 1.25 and the maximum will be 2.08. Next we have decimal scaling. So max value is 1000. To take it less than 1, we divide it by 10 raised to power 4, which is 10,000. So minimum value will be 0.02 and maximum will be 0.1. Next question 15th, we have given value V is equals to 35. Minimum value, which is min A, is 13. Maximum value, max A is 17. Mean MU is 29.77 and standard deviation sigma is 12.94. So first, what we wanted is min max normalization. After solving it, we get min max normalization is equals to 0.386. Now next, z-score normalization. After solving, we get z-score normalization as 0.404. Decimal scaling, max value is 70, smallest power of 10 greater than 70 is 10 raised to power 4, which is 100. So we get our decimal scaling as 0.35. So D, which is most appropriate. So the most appropriate is z-score is best here. Reason, the data set has a significant outlier. Min-max normalization is highly sensitive to outliers, and z-score handles this better by using the mean deviation. So here is a diagram. You can go through this. Next, we have 16 question in this using age and productivity data. First, we have A, normalize using z-score. B, compute Pearson's correlation or coefficient and covariance. Comment on the relationship. So step 1, we have z-score normalization formula, which is age norm is equals to age I minus new age upon sigma age, and uh, prod norm is equals to prod I upon new prod upon sigma prod. This standardizes both scales so they can be compared directly. Step 2, covariance. So formula is given here. Calculation, we multiply the deviations of age and productivity with each student and average them. Result, since older students generally had higher productivity, the covariance will be positive. Now we have step 3. In this, first we apply the formula and our range will be minus 1 to plus 1. Then we analyze. Then here analysis is given, and the our comment will be our answer will be based on the visual scatter plot from Q4. The relationship is positive. As age increases, self-assist productivity tends to increase. Now, next question number 17, in which student project evaluation scores are given here. And then we have part A, B, and C, which we want to solve. So the data shortlisted is, and हमें given है 12. So first, equal frequency partitioning will be logic divide data. So each bean has the same number of items. Let's choose three beans. Items per bean is equals to 4. हम थ्री बीन चूज कर रहे हैं. हर बीन में चार आइटम्स होंगे. Bean 1 to 3. Each bean have 4 items. So result good for handling outliers. Keep data uniform. Now be equal with partitioning logic. Divide the range into equal intervals. Range max minus min, which is 210. Let's choose 3 bean. Width is equals to 210 by 3, which is 17. So our intervals will be 5 comma 75, 75 comma 145, 100 comma 145 comma 215. So bean 1 we have 9 items, bean 2 we have 1 item, and bean 3 we have 2 items. Result heavily skewed because of outliers 204 and 215. Next, see we have clustering, k-mean approach, logic group values that are close to each other. Looking at the data, there is a huge jump from 92 to 204. Cluster 1, small or medium we can say. So it will go from 5 to 92. Cluster 2, high or outliers we say 202, 215, or split into two natural groups. So there is low, medium and high. Next, we have 18th question. In this, we use a flowchart to summarize the attribute selection techniques. We have A forward selection, backward elimination, and hybrid method. What is our goal? Select the best subset of features to reduce computational cost and avoid overfitting. First, we have forward selection, the builder approach. Start with an empty set, test every single attribute, pick the best one, add it to the set, repeat until performance stops improving. Second, backward elimination. Start with all attributes, test removing one attribute at a time, remove the worst one, repeat until only useful feature remains. Hybrid method. Combine both step 1 and step 2, then repeat. Flowchart structure: start, choose method, then loop, then check stop condition, then final subset.